Hello dear students, welcome to physics online session. So today we are here to discuss about that relation between current and magnetic field here. Already we come to know about that current as well as magnetic field individually. I know the meaning of current, and individual I know the meaning of magnetic field. From that Oersted experiment, as I said, that whenever that there exists a current in the wire, around the current carrying conductor magnetic field is present. It means that I want to find that what is the relation between current and magnetic field. In order to get that relation between current and magnetic field, so we can consider that magnetic field due to current carrying element. So that magnetic field due to current carrying element, so that concept is given by Biot Savart. Now in today's session we will be discussing moving charges and magnetism by that Biot Savart law. So from that Biot Savart law we are having lot of applications by taking use of Biot Savart law. First I need to understand what is Biot Savart law and what is the mathematical expression for that Biot Savart law. So today's session we will be discussing about magnetic field due to current carrying element. Magnetic field due to current carrying element. So that magnetic field due to current carrying element is given by Biot Savart. In order to get that relation between magnetic field and current, we will use Biot Savart law. Remember one thing, which equation will give that relation between current and magnetic field here? That is Biot Savart law. Biot Savart law. So from the Biot Savart law we will get that relation between current and magnetic field, right? In order to get that relation, first let me take one conducting wire. For example, treat this is one conducting wire. For example, let XY be the one conducting wire. Let XY be the conducting wire carry a current. In this conducting wire it will carry certain amount of current. That magnitude of current in general I will take it as I here. So let XY be the conducting wire carrying current I here. It will carry current I here. Now I will choose one point of observation at a certain distance from this wire. So that point P I will take it as point of observation. Let me choose one point here. For example, P is the point of observation where that magnetic field is to be determined. So simple thing, whenever there exists a current in the wire, there will be magnetic field around the current carrying conductor. For example, this is one current carrying conductor. Here current is passing, means nearby this wire magnetic field is present. So my interest is to find out that what is the magnetic field at this point. So did you get my point? I want to find that magnetic field at the point P. Let P be the point of observation. Let P be the point of observation. Let P be the point of observation where magnetic field is to be determined. Okay. In order to find the magnetic field at this point, I'm not supposed to take that entire conductor. In that entire conductor, I will choose one small length element. Look at here. In that entire conducting wire, I will choose certain length element here. For example, this is the small portion I can consider. So this small portion I can take it as length element. That length element, let it be d of L. Did you get my point? I will choose that small length element in case of that conducting wire. That small length element I will take it as d of L here. Now I can write d of L be the length element. d of L be the length element, d of L I will take it as length element here. Now this point of observation is at certain distance from this length element. For example, the distance between the length element and point of observation, so this distance I will take it as R here. What is that? Distance between length element and point of observation here. Distance between length and point of observation is R. D of L be the length element and R is the distance between DL and P. R is the distance between D of L and P. Now I can consider that magnetic field at point P is proportional to what are the factors. From that experiment we may come to know that magnetic field means magnitude of magnetic field at point P is depends on. So this is about Biot Savart law. First I can consider magnitude of magnetic field at point P is depends on. I want to find out that on what factors the magnitude of magnetic field at point P is depends here. For example, magnitude of magnetic field at point P is depends upon that first thing, it depends upon the current. For example, if the magnitude of current is more, so that current is passes through that small length element here. If magnitude of current is more means magnitude of the magnetic field at point P is also more. Did you get my point? If the magnitude of current is more means magnitude of the magnetic field is also more at point P. Then what is the first dependent factor? So first dependent factor is current here. What is that first dependent factor? So first dependent factor is current here. For example, in order to get that magnetic field at this point P, if the magnitude of current is more at this length element, if the magnitude of current is more means you will get maximum magnetic field at point P here. Second dependent factors I can consider here. So magnitude of magnetic field at point P is depends upon the length element. For example, if you choose small length element, so if you choose small length element, small magnetic field is produced. If you choose that large length element, you will get that large magnetic field. It means that magnitude of magnetic field at point P is depends upon the length element. Second dependent factor is it depends on length element. It depends on length element. Length element means D of L. Next one. Then the magnitude of magnetic field at point P is depends on angle between length element and distance here. Look at here. The magnetic field at point P is depends upon the angle between length element and distance. So theta is the angle between length element and line joining that length element and point of observation. Look at here. The magnitude of magnetic field at point P is depends on angle between length element and distance here. So next thing is it depends on angle between or sign of the angle between. Depends upon sign of angle between DL and R. So it depends upon the sign of angle between DL and R. So sign of angle means I can take it as sin theta. And one more thing, the magnitude of magnetic field at point P is inversely proportional to square of the distance. It means that if you take that point of observation far away, so for example this is the length element, you can consider if here the point of observation means here magnetic field is maximum. If that point of observation is away from the wire, so this is the wire, point of observation if you take away from the wire, then strength of the magnetic field goes on decreases. So it is inversely proportional to square of the distance between length element and point of observation. So look at here, we were discussing about that strength of magnetic field at that point P is depends on what are the factors. If you send that maximum current, you will get maximum magnetic field. If you choose that large length element, you will get maximum magnetic field. And so the magnetic field at point P is depends on angle between length element and this line joining here. And fourth point is it is inversely proportional to inversely proportional to square of the distance between length element or wire, you can consider this is inversely proportional to square of the distance between length element and point of observation. It means 1 by r square. Look at here. Here we are discussing about that magnetic field at point P is directly proportional to current, directly proportional to magnetic field, and it is proportional to angle between length element and line joining here, inversely proportional to square of the distance. By taking consideration of these points, I will give mathematical expression for this observation. Magnetic field I can consider, magnetic field is represented by the symbol B here. Change in magnetic field, you can take it as d of B. Magnetic field at that point P is directly proportional to current, right, and it is directly proportional to length element, right, and it is directly proportional to angle between length element and line joining, and inversely proportional to square of the angle between them. So d of B is proportional to I into d of L into sin theta divided by r square here, right. If you remove this proportionality sign, I will get that proportionality constant. D of B, it is equal to mu naught by 4 pi. Instead of writing proportionality sign, I will take that proportionality constant, so that value is mu naught by 4 pi I into d of L sin theta divided by r square. In case of Coulomb's law, you write that F is equal to 1 by 4 pi epsilon naught. In the similar aspect, d of B is equal to mu naught by 4 pi I into d of L sin theta divided by r square. This is the required expression for Biot Savart law. For theory examination, most of the time they will ask that Biot Savart law for 3 marks. So state and explain about that Biot Savart law. There is no statement, just you have to write the point and just you have to write the dependent factor, and finally you may write that formula for the Biot Savart law. D of B is equal to mu naught by 4 pi ideal sin theta by r square. You may spell it as, how to spell this one, mu naught, where mu naught represents that permeability, whereas epsilon naught represents that permittivity. Here mu naught represents that permeability. What's the word mean of permeability? So permeability means ability of the material which allows the magnetic field lines. So permittivity means ability of the material which allows the electric field lines. For example, between two plates, for example air medium is there, right, air will allow the electric field line at different extent. Instead of air, if liquid is there, water is there, water allow the electric field at different extent. So different materials will allow the electric field at a different range here. So that is permittivity we can consider. Here permeability means ability of the material which allows the magnetic field lines. Air will allow the magnetic field at different extent, like that water will allow the magnetic field line at different extent, copper will allow the magnetic field lines at different extent here. Here mu naught represents that permeability. What does that mu naught represent here? permeability. Mu naught represents that permeability. What's the mean of that permeability here? Ability of the material which allows the magnetic field lines here. So this value mu naught by 4 pi value is constant, so that is 10 to the power of minus 7 here. Look at here. Here we can consider that mu naught is permeability, so its value is 4 pi into 10 to the power of minus 7 Weber. So what is the SI unit of magnetic field? Tesla you can consider, or you can consider as Weber here. Weber per meter per ampere. What is the SI unit here? Weber per meter per ampere. Or also we can consider this one as another SI unit we can consider. Look at here. I want to find out that mu naught SI unit, right? For example, d of me means Tesla meter square. Look at here. Another SI unit we can consider Tesla meter square ampere. Here length element is meter. Here Tesla per ampere meter. What is the SI, another SI unit? Tesla per ampere meter. What is the another SI unit for that mu naught here? Tesla per ampere meter. What is the value of mu naught here? Mu naught is equal to 4 pi into 10 to the power of minus 7, or mu naught by 4 pi value is how much? That is 10 to the power of minus 7 here. Look at here. Mu naught value is 4 pi into 10 to the power of minus 7, or mu naught by 4 pi value is 10 to the power of minus 7 Weber per meter per ampere, or also we can take it as Tesla per ampere meter here. This is the equation for the Biot Savart law. Now what is the vector form of this Biot Savart law? Vector form of the Biot Savart law is mu naught by 4 pi I into d of L vector r divided by r cube. This is the vector form of the Biot Savart law. Write that vector form of Biot Savart law. D of B is equal to vector d of B is equal to mu naught by 4 pi I into vector d of L cross of vector r divided by r cube I can consider. So this is the vector form of Biot Savart law.